Hello friends, welcome to the first algorithm of data science, that is the regression methods. Regression, you might have heard about this particular terminology for multiple number of times. This is the first algorithm we are going to see in supervised category and in the regression category of supervised learning. Now, what do you mean by the regression? You might have seen this term multiple number of time in the statistics. Regression analysis is a very widely used statistical tool to establish relationship model between two variables or multiple variables also there. Two variable is basically referred for the linear regression. Okay, so one of these variable we called as predictor variable. Like input variables, already we have seen this in last presentation, whose value is gathered through experiments, and the other variable is called as the response variable, that is output variable. Its value derived from the predictor variable by some relations. There are three different types of regression methods available. So actually 12 methods are there in statistics. All of there are some specialized kind of regression methods, but very generalized and commonly used methods are linear regression, multiple linear regression and polynomial regression. In regression category, there is one more algorithm called as logistic regression, which is used for classification kind of outputs. So these three techniques we are going to see. Out of these three, first technique we are going to see in this video, and remaining two we'll see in the next video. So let's start with the linear regression first. We'll revise our knowledge of statistics about linear regression. So in linear regression, these variables, two variables are there related to an equation whose exponent or power of these two variables is 1. Means they are just simple general purpose constants present here. Mathematically, when you plot them, so it creates a straight line on the graph. A nonlinear relationship will contain exponent of any variable is not equal to 1, means exponent will be 2, 3, 4, or exponent will be minus 1, minus 2, minus 3. So it creates a curve in that case, and that is what we call as polynomial regression. So generally, okay, you might have seen this kind of equation. This is equation of a line y is equal to ax plus b. So generally in mathematics given mx plus c. So here y is the output variable, x is the input variable, means y is the y-axis variable, x is the x-axis variable, and a is called as the slope. Basically it's a constant value, it's a slope of the line, plus b, or here c is written, so that is called as the y-intercept. So how exactly it is there? Now see, just consider two relationships are there in linear and negative linear, positive and negative linear. So this is your x-axis and this is your y-axis. Now two entities are there, they are connected to each other. When x is incrementing, accordingly y is also incrementing on it. So here from this side x, from this side y, x, here y, x again y, x again y. So as x is incrementing, y is also incrementing proportionally to it. So when such kind of dependencies are there, we are going to apply this particular equation of linear regression, that is y is equal to ax plus b or y is equal to mx plus c, where we are knowing the value of m is the slope and c is the y-intercept. Okay, so slope means what? Slope means slope of this particular line. Okay, this one. This is first coefficient that you multiply to x, and second where y is intercepting. This line is intercepting here. It is intercepting on the y-axis here, that is called as y-intercept. So these two values are there, which are calculated from this particular equation when you plot this x and y together on a two-dimensional plane here. Similar to that, so this is what we call as positive linear relationship. Now this is negative relationship. Negative means when x is incrementing, y is decrementing, or vice versa. Means x is incrementing, y is decrementing, or x is decrementing, y is incrementing. So anything can be considered there, but they are connected through a linear relationship. Okay, whether it is positive linear or the negative linear. So when such kind of situations are there, we are going to apply the linear regression algorithm there. Now let's take an examples, applications like trend lines. A trend line represents the variation in some quantitative data with passage of time, like GDP. According to time, GDP changes. According to time, oil prices changes. These trends usually follow the linear relationship. Hence, linear regression can be applied to perform the future values of it. Okay, they are changing along with some, like if value of dollar changes according to the value of oil prices changes. So dollar and oil prices are connected to each other. They are linearly connected. They are proportionally connected to each other. Now economics. to predict the consumption of spending, fixed investment spending, inventory management, purchase of countries' exports, pending on exports, imports, like all labor demand. So everything is connected to each other. So this connection is linear, positive linear, or can be negative linear also. In finance, capital price assess model use linear regression to analyze and quantify the systematic risk of an investment. Similar to that, in biology also, some linear model causal relationship between parameters of biological systems are also possible. So we need to make sure that two entities, one dependent variable whose value changes according to another independent variable, that is input variable, as it changes. Okay, so this can be positive linear or it can be a negative linear relationship created with the help of this particular thing that we term it as the linear regression. Now, so let's understand that we have understood the concept of linear regression. Now let's apply this particular technique in the practical scenario. Now let's consider, in this particular presentation I am going to show two practical scenarios where we are going to apply linear regression. So here we are going to make use of pandas, numpy, matplotlib, and the last package also, that is scikit-learn. So pandas we require for data analytics, numpy we require for numerical computing, matplotlib.pyplot we require for the visualization of the data in the linear format, and sklearn, that is scikit-learn, is required to build the algorithm based on the linear regression classes. Okay, so let's take a simple example first. Now a simple example of regression is predicting the weight of person when the height is known. Okay, so let's understand the concept first. You might be knowing that the height and weight of the person are proportional to each other. It means that when height of the person changes according to weight changes, height changes according to weight changes, but not vice versa. Weight changes, then height will change. It is not, and connectivity there. Connectivity is present, but if you think logically, height is your input variable and weight is your output variable. So weight changes when height changes, okay, but not vice versa. So we can easily identify what is your input variable and output variable. Okay, so we'll build a model of this, whether these two entities are they are connected through an linear regression or not, or linear relationship or not, that we can formulate by linear regression here. So what we'll do, some 5 steps I mentioned over here. Carry out the experiment of gathering sample of observed value of height and the corresponding weight. Let's take 10 persons. Their height and weight I will calculate, I will take and create my data set. Okay, so when height was this, weight was this, height, weight, like this data set I will formulate. Okay, this is what machine learning requirement is, the previous data, observations, or the previous experience, human experience that we consider. Okay, so that will be taken first. Then create the object of linear regression class. So remember, for all machine learning algorithms which we are going to see theoretically, their classes or their implementation is done in the form of classes in the scikit-learn package, sklearn that we call in general programming. Then after this, we are going to train the algorithm with the data set of x and y. So train your algorithm with x, and x is input and y as the output of it. Okay, training, that is what we call as fitting the data to the statistical model of the algorithm. Then get the summary of relationship model, you know, the average error in the prediction, this is called as residual errors. Okay, get the summary. So once the model is built, then we can see how accurately the data is fitted to the linear regression model here. So that's what we call as accuracy score of this algorithm. It means that how much linear relationship all this data follows, maybe 100% or 90%, 20%, 50%, whatever. Okay, that we can see, and the difference from 100 is called as the residual error. And then last, we can predict. To predict the weight of a new person, we can use the function called as predict. With the help of predict method of the linear regression class, or every machine learning class contains it. For here in our case, it is linear regression class. From linear regression class predict method, we can easily predict the weight of the new person when the height is given as input to it. So this is what exactly the strategies of machine learning algorithms are deciding. Okay, so we are going to use this. Let's start with the first. Now this is your sample data, so I'm not going to use the CSV file for first example. For second example, I'll show the CSV file. So some of the samples values of height and weight are given over here. For example, so I gathered this information from 10 different persons. So when height of this person is 151 centimeter, their corresponding weight is 63 kilograms. 174 centimeters 81 kilograms, 138 56, 186 91, 128 47, go on. And last, 131 centimeter is height, 48 kilograms is the weight of this particular person. So in this way I have gathered my data set by human observations. And now let's understand, is there any linear relationship that these two values input and output are containing with the help of model building of the linear regression class. Okay, so that can be done directly by using the sklearn. And now let's go to the Jupyter notebook to understand how exactly these formulations of the regression model, linear regression model, can be done easily with this. Okay, so let's open the Jupyter notebooks. Yes. Okay, so I created the program already. So let's understand how exactly this should be done. Yes. So let's see this. Yes. So these are the first input set, sample heights in centimeters, whatever I have shown in my presentation. Okay, so these values are present there. X, sample heights of the person, 10 persons are there in centimeter. Make sure that this data I have saved in 2-dimensional array. For every machine learning algorithms, the input data should be present into 2-dimensional array. Okay, maybe in 2-dimensional array or will be in the data frame format. Okay, data frame is also 2-dimensional array kind of things, but 1D array is not given taken by any kind of algorithms. So you have to make sure that when input is single, we need to convert that single dimension input in 2-dimensional input. 2-dimensional inputs there. Okay, fine. Now let's go for Y. Corresponding weights in kilograms. Now this is output variable. One more thing you need to remember, that generally in all data science applications, now onwards, whatever algorithm we are going to see, everywhere we are going to make use of X as the input variable and Y as the output variable. So X is input and Y is the output variable. You need to make sure X is input and Y is the output. These are the common convention that we use. This is not compulsion, but these are the conventions that we are going to use over here. Okay, so with the help of this convention, it is easy for identification of input and output variable. That's why these conventions are preferred over here. Okay, now let's go for the next one. Now import the class, regression class. Look at that. So I'll just run this line. Now import the linear regression class. So here from sklearn, remember, for every machine learning algorithm a separate sub package is formed in sklearn, scikit-learn. So for our case in sklearn, we are having linear underscore model sub package, from where we are importing the linear regression class. So linear regression is a class. There is a common convention used to represent the classes. We have seen that if multiple words are there, every word's first letter in this class name is capital. Okay, linear regression, L and R are capital here. Remember this. After that, so this is imported. This is what we are using, selective import. So only that class I am importing, because scikit-learn is a very big package, and if you import the whole, it will take some time for importing. That's why, to reduce that time, I am using the selective import mechanism here in for the scikit-learn to import the linear regression class. Okay. Now after that, create the object of it. So let's create the object. This is how object of linear regression is created. Basically, see one thing that to remember, linear regression class constructor is called over here. Okay, but inside the linear regressions class constructor, there are some default parameters are also available. Okay, that I am not given that, but default values are taken over there. With the help of that default values, the constructor of linear regression class is created, or object is created. Basically, here I have given the name of object as regressor. Okay, so object is created. Now after that, training, the most important part in the algorithm is to train algorithm with the given data. That is fit. Fitting means training the algorithm, statistical model of the algorithm with the given data is called as training. So let's train that. Regressor.fit, X is input, Y is output. So your algorithm will take this data and will try to fit this data into statistical model of the linear regression class. Okay, let's see, regressor.fit. So as soon as you train the algorithm, it will print the constructor of this particular class with the default values or modified values given to this class by you. Now here see is showing that constructor on the screen. I have not given any values, so default value is taking. Copy the X value or not, true. Fit the intercept, generate the intercept or not, true. Okay, number of jobs, none. This number of jobs parameters are available to almost all kind of ML algorithms. When you are going to learn these algorithms parallelly on distributed system, that time this parameter should be given. Then normalize equal to false. Normalize equal to false. So normalization we are applying here or not. So generally for linear regression system, normalizations are not required. We can normalize the data, but it is not expected to normalize it. So normalize, I am giving false. Okay, fine. So it is fitted. Now the model is fitted and it has found the statistical model of it. So it means that in linear regression class we found the value of slope and we found the value of y-intercept also. Okay, these values are present inside the regressor class. Now the final step or one more step is present. You can find the accuracy score of this algorithm also. Let's see. For example, I want to find, now it's created, I want to find weight of or height, weight of a person whose height is 175 centimeters. So for that purpose I am creating a variable new here. New is equal to, in double square bracket I have given 175. Okay, so 175 is given here, and now regressor dot predict new. Okay, so it's predicted. Fine. Regressor dot predict new. So new values I am giving here. As we have seen, we have built the model is perfectly created, and now to automate the system, new input we are providing, and according to model build, algorithm will generate the new weight of the person. Let's see, the new weight of the person is 79.60 kilograms. Okay, so I predicted this value here. The predicted values are in actually in array format. Okay, that's why I'm printing here 0 is used over there. If you don't use this 0, it will print like this. See, it's in array format, single value, but it's array. So I want that 0th value, single 0 value from there. So I just use this. Okay, so predicted these values based on the new value 175 is predicted value is pred. Okay, so height of the person will be pred of 0. Okay, so this value is 79.60. So this is how actually machine learning algorithm behaves. Okay, the things which I have shown over here, based on that the prediction is done clearly. Now let's change this value. Okay, so I'll make it 183. Okay, now try this. See, it is 84.99 now. So we just change value accordingly. I just decrease it a lot, 156. Okay, now see, it is 66.84. Because the model is created, linear regression model is created, and it is predicting the value based on that linear regression model here, and I am getting the output accordingly. Now what's the accuracy of it? Let's see the accuracy. Here the accuracy, to find the accuracy of algorithm, there is a function called a score. Method is there, it's called a score. Regressor dot score input and output. So when I am giving this input and output and into 100, so the value is returning actually between 0 to 1. That's why I am multiplying it by 100. So I am getting now accuracy is 95.47%. Okay, 95.47%. So this is the accuracy of the algorithm for this kind of the data set here. Remember, 95% they are correct. Yes, that is correct. It means that the data is linearly connected by 95.47% time. Remember it. Okay, and now what's a coefficient value? So in once you have fitted the data, then automatically it has calculated the coefficient. Coefficient means the slope and the intercept also. See this, the slope is 0.67 whatever, okay, it contains there, and intercept is minus 38.455. okay, so these values are calculated here. It's calculated, and now see, let's understand that how it is actually calculating the data. 156 is present here. If I write 156 here, it means that, see, this is slope into, okay, so m x minus plus c, so it is containing minus here. Okay, and we will calculate that. See, 66, I got this value here, 66 point something, 156, and here also the same value is calculated. Okay, fine, but these values are different here actually, so that's why it's generating somewhat different. Okay, this value I need to put here. Okay, 0 point something like this, and this is your coefficient, y-intercept, sorry, yes, 66.78 like this. So in this way it is calculated. It means that calculating the coefficient, that is slope, and the intercept is done by the algorithm, and based on it is generating this particular result here. Getting it? So this is how simple ML algorithm behaves. Now let's do one simple example here. One more thing you to remember, that if I am giving the same values again as input, see y is the weight of the persons, and if I giving x again, it is changing a bit. This is what we call as residual error, 63. And if I given this value again, output is 63.41, here 81, 78, means according to algorithm is calculating this 63, 78, here 56 is there, calculating 64.64, then 91 is converted to 87, 47 is 47.89, like. So it means that human collected values are not 100% correct. There is a 95% possibility is there. That's why this 5% error is represented in the original data also. Now let's plot this and let's find whether this algorithm is actually generating the data in the linear fashion or not. So to do this one, so what I have done here, I am putting the matplotlib, and now let's plot this x label, height, and on y side I given the weight. I am using a scatter plot here. Okay, simple scatter plot. To represent it, I'll just put it in comment, and now let's see the output. Okay, so these are the original values of height and weight that we can see here. Okay, original values of height and weight, and their graph is visible over here. Fine, x and y. And now let's see if I am generating the values according to the formula. So x is same, that is your input is same, but output I am generating, y I am generating by the formula, by the regressor.predict function, which is generating the data as per the formula of linear regression. I am giving the color red there, and using plot function means line plot is plotted. See this. Okay, so red color is the actual value calculated by the formula, which is coming exactly linear, and the blue color dots, these are the original values which are calculated by, or which are collected by the human. We are not exactly linear. So the difference of this particular point from the center of the line is called as residual error. So this is very important error. We need to reduce this error. We need to make this point as close as to the center of this particular line to reduce the error. So when they are exactly on the line, your result will be more and more accurate. Okay, some more exactly on the line. You can see they are almost on the line. This one, this particular point, I think it is around 70. Some value is present, which is around 70. 71.76. I think this number is there. This input expected value is 72, is getting 71.50, something like this. Okay, so this value is exactly almost on the line generation of the data. Here also 63.41. This is the first point. Sorry, not this. I think this point is there, which is this point is there, which is almost onto the line. Okay, it's generated by the algorithm and original data set that we are having there. So algorithm is trying to fit the data as close to the line and finding the most accurate model. So most accurate model here contains 95.47% accuracy. Okay, so okay, let's understand. So that's what your simple program is present here. Now I'll go for identifying whether it's behaving correctly or not. Let's see. So what I've done here, two variables I have created, A, B. So 100, 2, 200, 3, 300, 4, 400, 5, 500, like. Then I have fitted this data. So let's fit this data to the regressor.fit. Okay, fitted. Now I'm finding the score. Let's see, it's exactly linear. You can see in the data set itself, 1 100, 2 200, 3 means 1 is input, 100 is output, 2 is input, 200 is output, 3 is input, 300 is the output. If the such case is present, it means that they are exactly linear. They are perfectly linear, connected to each other. That's why output generation prediction is done perfectly. And if I write 23, I'll get 23,000, 2300 output as it is. And for plotting also, I'm plotting this. Check this. A perfect linear output I'll be getting for all 5 values. Means human collected data is also linear and computer identified data is also perfectly linear. That's why a perfect line I'm generating out of it. That is what the linear regression is. A common, simple and basic example that we have seen here on linear regression class. Okay, now let's go for using more practical application of this particular concept of linear regression, and from there we'll formulate the concept of this linear regression by some more useful mechanism there. Now let's go for this. So CSV file that we are having here, file name is salary.csv or salary-data.csv. We can download this file from the same location, mitu.co.in/dataset. Okay, From this data link we can download this particular file and perform the operation. So let's open that. I'm having this file with me. I'll open this particular file. Let's see. In my case its name is salary.csv, maybe it's salary underscore data.csv. Okay, so let's open that and let's try to identify what this file is actually containing here. Okay, okay, so years experience. So this data I have collected from one of the organizations where the employees experience is given and their salary is provided, and all of their post is almost same. Okay, so based on that the salaries are provided here. You can see as experience grows, salary is also growing almost. Okay, not 100%, but almost it's growing there. Let's build a model on this particular data of salary, and then we'll form how exactly to read the CSV file, how to build this machine learning model of linear regression with the help of this particular data set. So let's go for this second step. Here we are going to apply the actual algorithms, actual methods of machine learning to formulate your output more effectively. Okay, now first of all, import all. We require pandas, we require np, we require matplotlib.pyplot. Now after that I'm going to read this particular file salary.csv. So data is equal to pd.read_csv salary.csv. So we have read this file and we have stored this data into variable data, and data is, we know that it's a data frame kind of object. If you print, the size of the data is something like this. Data size equal to data.shape. Okay, so shape means 30 rows and 2 columns are present. What are the column names? Okay, this one, years experience and the salary. These are the 2 columns which are present there. Now out of these 2 columns, which is your input? Years experience is input and salary is the output. So you must be knowing the dependency concept. Remember, when experience grows, salary will grow, but when salary grows, experience will not grow. It means that salary is the output variable and experience is the input variable. So based on that I have separated, I'm going to separate them in the x and y format. Let's see this. So I'm using this x is equal to data of years experience dot values I'm using to convert it into the arrays format, else it will be in series format. Okay, so it will be converted in array format. Why I'm doing this one? Because I need to convert this data into 2D format. Because one more important thing to remember here, when I'm extracting single column that we have seen in pandas, when we extract the single column will be in series format. It is not containing 2 dimensions. In the last program also I mentioned, every machine learning algorithm will take the data always in 2-dimensional format. So here it is single dimensional. That's why I need to convert to 2-dimensional by using a reshape method of numpy array. So to do this one, I am converting this data into arrays format. That's why this method I have done. Then y I am taking. Okay, so let's add one extra cell over here, and let's try to find cell below. Okay, so let's see x. So x is the array, the array created, 1D array created, and y is the series whose output variable is this. Fine, getting this. So this is how the data is presented. Now I want to convert this data into 2D array format. To do this one, I'm having this array variable dot reshape -11 will convert the row vector into column vector. So what do you mean by row and column vector? See, this is the row vector. Okay, single row is present, and if I reshape it, so let's reshape it. Once the reshaping is done, I'll insert one more row below to it, and now let's see the output. So this is 2D array in column vector is converted. Check it out. 2-dimensional array is created there. Every individual entry is containing one row. Fine, but array is in 2D format, and if you see the shape of it, see 30 rows and 1 column is present. 30 rows are there and 1 column is present in this particular data set. Okay, fine. So in this way we are getting this particular output. Now let's check the accuracy, or let's identify whether output generated is correct or not with the help of the train test split. So I'm importing the train test split function from sklearn.model selection. We have already seen the application of train test split. So by using training data we'll feed the we'll create the model, and by using testing data we'll find the accuracy of this algorithm when it's generating correctly or not. Okay, so to do this one, so what I've done here, so let's see this. Sorry, okay, here x train comma x test comma y train comma y test is equal to train test split x comma y. Test size I am giving 1 by 3. 1 by 3 means 33% data will go to test. That is 10 entries will go there. I'll make a small change here. I'll make it 0.25. Okay, test size 25% entry will go to test and 75% entry will go to train. Random spread I am keeping 0, so everywhere randomization of the data will be same. That's why I am doing this one. So data is split it. The length of x is 30, length of x train is 22 and length of x test is 8. Means 22 entries will go to training data and 8 entries will go to testing data. So for 8 entries I am re-providing them to the prediction function, and based on that will generate some results out of it. Okay, in salaries of the particular person which experience is given there. Okay, so let's go ahead. Now let's form the model now. So here splitting is done. We'll read the linear regression class just like in previous example, create the object of it, and now train the algorithm with the given data, x train, y train. So only 22 entries I am giving to build the regression model there, fit the data to the respective linear regression model, and after that find the score of it. So let's see the score, 93.95%. Okay, so data is connected in linear format but in 93.95% way. Getting this? Okay, and if you apply the test data, so test data contains 97.79% accuracy there. Means test data is actually containing more accuracy that the model is corrected over here. And now let's have the most important example. 8 entries are remaining here. So test data contain 8 entries, means 8 salaries, and this 8 salary will be provided based on that, 8 experience. Based on these 8 experiences we'll find the 8 salaries predicted by the regressor object here. It will be predicted by the regressor object here. Okay, so let's predict that, predicted, and after this I'm going to create that in the data frame format and print it. Let's see. So result is equal to pd.data frame. Here I am creating a data frame manually. First of all, actual value whose values are y test and predicted by the algorithm which are y pred. They are given over here, and then this data frame is created, and now print as data frame. Now let's see what exactly we are going to have it here. Check it out. So actual values are 37,000. Okay, for entry number 2 in that data set, and predicted by algorithm is 41,000, 28, 1,22,000, 1,23,000. Almost they are close to each other. 57,065, it is having 8,000 difference here. 63,218, 63,567. This is also almost close to each other. 116, 116. Yes, this is almost we are getting the correct output from the linear regression. So we can easily predict the salary of the person whose experience is given to you based on this particular data. Now 1,09,000, 1,08,000, 1,12,000, 1,17. Here we have 5,000 difference. 55,064. We are almost having 8 to 9,000 difference between these two also. But okay, that's fine. We can predict the value, and based on that we can identify whether your algorithm is behaving correctly. Yes, almost. If you see this table, we can almost identify your algorithm can behave correctly. 93% accuracy is present there. For test data we have 97% accuracy. So this is what the test data we are given, which contain 97% accuracy. And let's understand, let's get one more data set data here. For example, in this data the years experience 20 is not given. 20 is not given. So let's find what will be the salary of the person whose experience is 20 years. So it is 2,14,000. So it is in array format. So let's use 0 here. So 0th entry will be formulated. 2,14,000 if 20 years experience. If 15 years are there, then what will happen? Yes, 1,67,000, like this. Go on using it. So just provide the input, okay, input variable, and based on that we can easily generate the output variable from there. This is what we are calling as a machine learning algorithm there. So machine learning algorithm of linear regression behaves in this particular way. Model is created and we are going to do the prediction. So here also we are having the value of coefficient and the intercept, okay, that we can find by using the regressor.coef underscore and regressor.intercept underscore, that we can make use of it. And now let's characterize the regression methods. To characterize the regression method, there are some ways are used. First is called as mean squared error. Mean squared error. Mean squared error, see, it's calculated by, there is one function, okay, so from sklearn I am importing a matrix matrix is a sub package. Say in matrix sub package, I'm going to have mean squared error function. Okay, let's see, MAC, y test and y pred again. Test means original value and y pred is predicted values. Mean squared error. It means that the mean of squared of all the values. Okay, the difference between y test and y pred, their mean and squared. Okay, that is calculated, and that we are going to have. This is a mean squared error there. This is mean square. How it is calculated? Let's take an example here. So example is this. See, y true original values are this, and predicted by algorithm is this. For example, 1 predicted 06A, 1 1.29, 2 1.99, 2 2.69, and 4 is 3.4. Okay, so if you calculate that, I am getting this. So this is how it is calculated. First value means y test minus y pred square plus second value same, third value square, third value difference square, next value difference square, next value difference square, and addition of all divided by total number of values. So this is how it is calculated. Check it out. 1 minus 0.6 square plus 1 minus 1.29 square plus go on using it 4 minus 3.4 square. Okay, it's calculated and divided by 5. It's called as mean squared error. So mean squared error can be found with the help of this particular mechanism in a regression method. So whenever you are using a regression kind of algorithms, this is linear regression. Even we are having non-linear regressions also. So in non-linear regressions also, we are going to make use of this particular formula to find the mean squared error. Mean squared error will perfectly characterize the regression algorithms. Okay, so there is one more method called as mean absolute error. Mean absolute error. Mean absolute error is a direct difference between the two values present there. Direct difference is there. Means difference between y test and y pred and their mean. Means for example, difference of these two divided by 8. It's called as mean absolute error. So it is, for our case, the mean absolute error is 3508. Means we are having the salary difference of average is 3000 almost. Okay, for all the average predicted values. Getting this? And to find the error, so we are going to make use of this particular method. Average NP contains a mean method, average calculated, y test minus y pred divided by y test. Okay, so I am giving ABS method here to find absolute values. It means that when values are negative, it will be converted to positive, that is absolute. Y test minus y pred divided by y test into 100, and average of all 5.26. This is the error that this particular algorithms or the predictions are containing. Remember this. This is how the algorithm actually behaves and perform the operations. And as we have seen in the previous example, we have drawn some charts, some linear graphs, some lines based on x and y. So here also this will be assignment for you to draw or to plot this x and y, means salary against the experience of the person, general values, and predicted by the algorithm values. So you can see how exactly these two values are linearly connected to each other. So try by your own. If any doubts are there, you can text us, or you can continue with the next videos of the regression method and mechanism. Thank you. Thanks a lot.